Hello and welcome to our latest Tech Savvy talk called But Why Go? Before we start, I need to tell you about a few housekeeping items. This lecture will be recorded and there will be a goodies giveaway at the end. On the left on your screen, you see a link to Slido, where you can join and ask your questions throughout the presentation. And with that said, let's start with this talk. I'm Nikola Aleksandrov, software engineer at Scalefocus, and today in this presentation, I will talk about Go. I joined the company in 2017. I have experience with a wide variety of technologies, including C# and in the whole .NET ecosystem, C, TypeScript, JavaScript, with some front-end libraries like React and Angular, and a little bit of SQL. In the last, in the past, I have primarily been working as a backend engineer with .NET, and in the last 2 years, I fell in love with Go. Today, I will try to explain why I think Go is a great language and why you should at least try it and maybe consider it for your next project. So this presentation will be more on the casual side. I will not explain in details Golang, how to write Go code and bore you to death with code snippets. Warning, there will be a few code snippets, so bear with me. I'll try to focus more on the mindset of the language and try to show you where Go shines and what new brings to the table. In the beginning, we will start with a little intro into Go, and I'll try to answer the big question that you might have on your mind. But why Go? These are in more details, the topics that we will try to cover. What is Go? A little bit about the Unix philosophy that the authors had, and Go approach to solid approach to code organization, and try to answer what makes Go so performant, and figure out, is Go any good for our business applications? Let's start. What is Go in a few words? Go is open source, type safe, reliable and efficient software. Simplicity was one of the main goals since day one. And this is why you hear me often repeat this keyword throughout the presentation. It was also designed to compile and run fast on a lot of platforms and architectures. But in order to understand more deeply, let's take a little peek at the history of the language and see where it started. The design began in late 2007, quite a few years ago actually, at Google. As a legend has it, Rob Griesemer, Rob Pike, and Ken Thompson were sitting around and waiting for a large C++ program to compile. So they had some time to think and discuss everything wrong with all the programming languages that they were using at Google at the time. Later, they were joined by Ian Taylor and Russ Cox. Ian Taylor created the FMT, the formatting program, and we'll talk a little bit about him a little bit later on. The first release of Go 1.0 was in early 2012, and the last version, Go 1.18, was released this year. Between 1.0 and the last version of the language, there are really a small amount of changes to the language itself. Since both the language and the standard library are backward compatible, code you wrote back in 2012 can easily run and compile today. Currently, Go is widely adopted and used in a wide variety of projects in areas such as networking, DevOps, database engines, streaming, APMs and virtualization and a lot more. Couple of brands are Docker and also the streaming platform Twitch. Okay, with the history that with this history, let's see what problems Golang tries to solve. What the authors were thinking back then. At the time of Go inception, only 10 years ago, the programming world was different from today. Production software was usually written in C++ or Java or C#, and most computers were not yet multiprocessors. The authors knew that parallel programming was the future, and they wanted to create efficient, fast, and in the meantime, fun and easy to use language. They wanted to address a couple of pain points: slow builds, uncontrolled dependencies. They wanted to have simple and concise syntax, first-class support for concurrency and parallelism, unlike in other languages where it was add-on. They wanted to fix the poor programming, the poor programming understanding. This means code hard to read or poorly documented code and so on. They wanted to remove the cost of updates, and they wanted a language that can be built in a cross-platform manner, cross-platform use. Compared to other languages, the Go syntax is quite small for simplicity reasons. Here are a few of the main concepts that we have. The first one, Go doesn't have classes, and structs are the main data structure for passing data around. They are pretty simple, as you can see, just a list of property names and types, and they can be used really easily. These are the building blocks. The next building block is called embedding, or oftentimes called composition. Is the main and only way of extending the structure behavior. Instead of inheriting features from a parent class or an object, larger objects are composed of other smaller ones and can thereby use their functionality. As you can see, dog is embedding an animal. Animal has a property called is cold-blooded, and dog is also a friend, and each friend has a name. Another main building block is functions and methods. Functions are just like in other languages. You can define a list of input parameters, the name of the function, and maybe the only real difference is that you can also have multiple output parameters outside the box. You don't need some wrapper structure or something like that as tuples or something like that. This really comes in handy because, as we are going to discuss later on, in Go we are treating errors as regular old values, as a return values. Methods are a little bit interesting. The only difference between method and a regular old function is that method has a receiver. Simply said, the receiver is just the type that the function attaches to. Nothing more, nothing less. And as you can see, the hello is a method of the struct friend. So hello can access the properties inside the friend struct. Sometimes we are also calling it a pointer receiver because usually this is a pointer. The last building block that I would say it is essential is packages. As you can see, packages are just a string name, and you can think of the packages as a namespace in C# as in packages in Java, but they are much smaller, much smaller. Each file needs to belong to a certain package, and you could also have subpackages. As we can see, we have the driver package, which can have subpackage SQL or non-SQL, for example, or many other drivers inside this package. But why Go? I think Go offers a unique way of solving some of our day-to-day problems, and with combination of simple syntax is the perfect new language for you to try. The creators of Go saw multiple problems back in the day in the other languages that they were using at Google. And they designed their own language with solutions in mind. They didn't want to repeat the same mistakes. Remember that they had a lot of time, so they did some bold claims. Here are a few of the approaches that they used in order to mitigate those issues. They started with the Unix philosophy. So let's start with this famous quote: small sharp tools combined to solve a task. Oftentimes, the problems are not obvious from the beginning. So we must try to design our software to be loosely coupled and easy to understand. This is a really core value in Go. This Unix philosophy and Go guide us to create simple and small as we can pieces of software that we can easily maintain and reuse. Here are a few examples of how this philosophy is applied. For example, there is no and there will never be a ternary operator. You already have an if-else block. Yeah, is it more compact than the ternary operator? No, definitely. But it represents the same code, and the authors didn't want to duplicate this functionality. In the beginning, it may sound a little bit not stupid or something like that, but remember, they wanted to build a philosophy around the language. Another example is, as you already saw, there are no classes in Go, because you can basically accomplish the same behavior by utilizing by combining functions with structs, and also utilizing embedding. Okay, one of the unique things that Go does is error handling. Typically, functions in Go return multiple values. 98% of the times, the last value is an error. This is because the authors realize that errors are just part of the business logic and should not be separated and handled differently from actually the expected result. This way, we are forced actually to think not only about the happy path in our logic, but to also handle errors gracefully. Since the error variable is right there in front of you. It is not hidden in some exception that you need to remember to catch and to surround or with try-catch block. It is just on a regular value. On the slide, you can see a convert function that accepts a number as a string and tries to convert the number to the string value to an actual integer. It is doing a little bit strange in the beginning. It is checking if the length of this string is 1. Why? It is not clear, but if it is bigger than 1 or different than 1, it will throw an error. The important part is how you're handling this error. As you can see in the main function, where we are calling convert 3, immediately after this, we are checking the error, and we can take some action and figure out how to deal with this error. If we try to, in this case, if we try to not process the error or not check the error message, the compiler most probably will tell us, hey, you have declared this error, but you're not using it. You're not using it anywhere. Another unique thing about Go, I think, is the lack of access modifiers. In Go, you don't have a plethora of access modifiers, as in other languages. There is no public, private, protected, internal, and so on and so on. In Go, life is really simple. If you want something or a property to something property or a function to be accessible from outside of the current structure, you start the name with a capital letter, and that's it. You might say that that we are missing some functionality here, but this functionality is actually we are able to fix this functionality by combining structs with also with packages. Packages are not one big bucket of code. They have more meaning. It is more. They contain more small pieces of code. So it is not like in C# where we have one namespace for the whole library. In this case, it is much more smaller. Packages are much more smaller scope. And the other thing is that I wanted to tell you about is packages. The only way you can bundle or organize the code in Go is by using packages. Packages are pretty simple. They are just a file in a folder. You can have only one package per folder, but you can have multiple files in this folder, so they can share the same package. One folder can contain only one package and many sub-packages, which are, you probably guessed it, in a subfolder. This way, Go forces us to structure the code in a tree shape, not in a graph. Since sub-packages cannot reference any other of cannot reference any of its parents. This is really cool, and this is how Go is solving the uncontrolled dependency problem. We are literally forced to write small packages in a tree shape. Let's take a look at Go and Solid, and in more details, one of the Solid principles, the open-close principle. And can you even implement the Solid paradigm? Yeah, without classes. Let's see if this task is achievable. The principle says software entities should be open for extension, but closed for modification. On the screen on the left, you can see that we have a type A struct with field year and a method grid. We have a second type B, which embeds an A. This colors CB's methods overlaid on A's, and because A is embedded as a field within B, and B can provide in its own grid method, obscuring that of A, Go achieves these tasks. But embedding is not only just for methods. It also provides access to the embedded types fields. In this as you can see, because A and B are defined in the same package, B can access A's private year field as if it were declared inside B. So embedding is pretty powerful, which allows Go types to be open for extension. And you can see that when we say grid a.grid, we will see in the standard output hello text 7 with year. And if we try to perform the same operation in B, we can see that the message changes, but the year is still taken from A. By the way, this is a really great example taken by Dave Chain, one presentation made by Dave Chain. But I do think it illustrates really cleanly this principle. Okay, so now let's take under the hood what makes Go thick and why it is so performant. Unlike many other languages, in Go, arrays of objects. I'm speaking regarding the values. So values in Go operate a little bit differently. Unlike many other languages, an array of objects takes exactly the size of the object times the length of the array, which means that if you want an array of 100 integers, it will take up 400 bytes of memory. This behavior is very similar for array of more complex objects. Since the values would be structs, they would be packed up closer together in a solid block of memory, not spread out as pointers to all over the place, which really helps CPU cache optimization. Because when the CPU has a concise block of memory, it runs really, the cache can be optimized, and our instructions can run really fast because everything will be pre-cached inside the CPU cache. And we have as a bonus that we can create a release array, or actually the only way of creating is we have a compact data structures, which to me is another benefit. And they are pretty simple. Yeah, I really encourage you to think about simplicity, and because yeah, I said this is one of the main goals of Go in Go. Another significant Go performance trick is inlining. So let's discuss how a function is called. By the way, this is the same for all languages. Three things happen, basically. A new stack frame is created, and the details of the color are recorded. So, this means that we are persisting the variables of the color. Any registers in the CPU, which might be overwritten during the function call, are saved onto the stack. The processor computes the address of the function and executes a branch to the new address. So this is a branch instruction. This is typically not that cheap. Our modern CPUs spent a lot of, and modern CPU designers spent a lot of time of improving something called branch prediction. And let's see how Go tries to minimize this problem. Because function calls are really common operations, yeah, we want to have a lot of functions and combine them in functions. We want to have smaller functions, which will inevitably increase the amount of functions in our code, and therefore the function calls. CPU designers have worked hard to optimize for this procedure, but they cannot eliminate all of the overhead. Depending on what the function does, this overhead may be trivial or significant. For example, maybe if the function is really simple, the CPU can optimize for this behavior. But if it's a little bit more complex, then it will perform some costly operations. These costly operations that we mentioned previously. A solution to reduce this overhead is exactly by inlining. What this inlining means. The Go compiler inlines a function by treating the body of the function as if it were part of the core. So how to explain more better? Basically, it copies the body of the function inside the parent function. It sounds a little bit strange, but let's see why. It only makes sense to inline where the overhead of the calling function is large relative to the work function does. So simple functions are candidates for this inline. So what are the performance benefits? We have literally eliminated the need for some expensive CPU operations by compiling our code a little bit more smarter. This is what is the trick here. And these performance benefits are one of the reasons why you should consider Go for your business application. Performance matters, actually. Nowadays, everything is in the cloud. What I was saying. Nowadays, everything is in the cloud, and performance matters. Time literally is money. If your application takes 2 times more to perform a certain operation, you literally pay 2 times more. What are the other reasons why I should consider Go for your business language? It doesn't seem that flexible compared to TypeScript, for example, or Java. Another benefit is startup times. Since Go is a compiled language, you don't need to start a virtual machine or you have anything installed on your server that you need to start before that. This, first of all, simplifies deployment, since you don't need a separate version framework to manage, and also increases the startup time. I just want to say that there are not a lot of compiled languages that can be used easily in modern applications. I don't count C++. I know that C++ is a compiled language, but C++ has its own drawbacks, as Go, actually. One other benefit is compatibility. Go has always been, and it will always be, a backward compatible language. At least this is what is promised to us, and it is kept true since today. At no point in time you need to deal with changing the code for a version upgrade, and the version is just a number in the Go mod file, which if you want for some reason to increase, you just need to increase it. This will, for example, help you use new features of the language. Example of new feature might be the newly added Go generics. Another benefit is Go is open source. Go is open source and therefore free. It is trusted and backed by a lot of reputable companies. You know exactly what code runs in your application, which is particularly good for security reasons. Another huge benefit, and that I really like, is that you can literally you don't need to spend time going into documentation or searching for documentation. You can hit F, navigate to the implementation, and you see typically well documented, if it is in the standard library, well documented code and pretty simple code. This is not true for every package, for every external library, but from my experience, the Go community continues to value those the well-documented code and values simply and well-written code. I want to say that the community is quite small, so it is not compared to other languages, is not that big, but it is really passionate, and I do believe it will also grow in the coming years. Another benefit is Go is multi-platform. It runs everywhere: Linux, Windows, Mac, whatever you want. This thing is not this benefit is not that common, actually. C# just in the past few years brought support for Linux, for example. And they did it only for .NET Core, some more or less special way. But yeah, .NET is improving, as every language in the world. Go started from here. Go is multi-architecture. Since Go is Go compiler is based on LLVM, It runs on every possible architecture that we can imagine: x86, x84, ARM, and even RISC-V or RISC-V, however you want to call it, and many more. And you can be sure that if there is a new architecture coming in the next few years, it will be supported, because the compiler will be really easy ported. One other thing is productivity, and not in the sense that you are productive, but more on the note that you can easily convert to Go from many popular languages, since Go is a C-based language and the syntax is really small. For example, you can really easily transition from C#, Java, PHP in a couple of days. It will not take you a lot of effort. This is because Go, in Go, what you see is literally what you get. You don't need to dig deeper. There are no pitfalls. There are, in most cases, there are not a lot of ways to do one thing. There are not a lot of examples of doing one thing in more than one way. Typically, we have one, how to say it, well-documented way, or well-known way, and that's it. And you don't need to dig through a ton of documentation and tutorials how to achieve a certain task. I know that from my C# perspective, the C# documentation is not that bad, but you do have a lot of reading to do in order to know how to do something in a good practice. Because of the small syntax, good practices in Go are they are good practices everywhere. So you don't have something specific to Go. As we said previously, you are encouraged to write small reusable functions that you can easily test, utilize interfaces. One thing that I didn't mention is that interfaces in Go are quite flexible things, and typically we declare the interface near to the consumer, and we do not store the interfaces in a separate project, for example, as it is commonly done in .NET. So, as my closing thoughts about Go, let me start with the quote from the beginning. All languages are both wonderful and terrible, and there is no single best language for every job. It doesn't exist. This is true even for Go. I do believe Go offers a few fresh ideas that to me are worth exploring, and they definitely enrich my views regarding the programming world. I encourage you to go learn Go, and definitely also learn other languages and try to pick the best ideas from them, because there is no single best language. Sorry. I'm sure that in the beginning, it will seem hard and maybe unnecessary to learn it, but do not be afraid of new approaches and new ideas. I'm certain that in the end of the day, this will make you a better programmer.